For instance, if we're doing a chunk size which is rather small, and we have also very unbalanced classes, it might be that in some of the chunks, we don't get the minority class. And if we don't have the minority class present in some of these chunks, then we can't measure combinatorial metrics like, for instance, ROC AOC. So that is something very important to think about when you pick the right way of chunking. And then there's another thing, which is also super interesting. And we're just doing group buys, but these things tend to become very complex very fast, is that there is this error that can occur, which has nothing to do with data drift and which has nothing to do with concept drift, but which is just plain sampling. So basically that's how the data is generated over time. If you have, for instance, risky customers and they just by sheer chance happen to do something very close in time, then they will be put in the same chunk. And then that is going to impact the performance. And what you see here in this give is you have some population of data points. And every time we just randomly sample and we put them in a different chunk. And these are all valid performance patterns that they can form. So here we see like the performance is like first going down and then up. But then we can also just see that there is a million different ways that this chart can actually look. And this sampling error is something very important to take into account because we don't want to alert or we don't want to go and delve and do a comprehensive analysis if our metrics are just changing because of sampling as opposed to something deeper going on. And that's why we also, as part of our open source library, we have this baked in and we use the standard error for that, but I'll touch upon that a little bit later.